Hello guys, welcome to the DMS Online School. In today's lesson, we'll be looking at a mathematics lesson on sets. Okay, so this lesson is on sets. So it is very important that we understand what a set is for us to be able to understand this topic on sets. So I am going to define what a set is for you to understand this topic because these definitions that are given are actually the concepts. So if we are giving out some definitions, then we are giving you what we call concepts upon which this topic depends on. Once you understand those definitions or concept, then you are going to understand the topic. So a set is defined as a collection of well-defined objects. So we are going to say a set is a collection of well-defined objects. So that's what a set is. So if we have objects that are well defined or explained, then we have a set. Okay. So the key word is here. Well defined objects. Then collection, we can also put it group where we are putting collection. We can also say group. A set is a group of well defined objects. Now, for example, PG, we can even say a set of girls maybe wearing red neck ties. We can also say a set of maybe red pencils. So these two which I've given are sets. What qualifies them to be a set is this. I've said a set of girls wearing red. So I've said girls that are wearing red neckties. So this one becomes a set because it becomes a collection of girls, meaning I have a particular group of girls, and this group of girls, it is a group of those girls that are wearing red neckties. So when you see them, they will look uniform actually, they will look similar. That is what we mean by defined. They will look similar, they will look uniform, and that will become now a set. That's why a set is a collection of well-defined objects. Or equally here, when I say set of red pencils, the objects that I'm talking about are pencils, but the pencils now in particular are the red ones. So it's like we have put all the red pencils, we have put them together. Now we can say a set of red pencils. Okay. Even here, like we are at school, we have girls. Okay. Now, these particular girls we are talking about are objects. Now, they are putting on red neckties. So when you see them, they all look uniform. So that's what we mean when we say a set is a collection of well-defined objects. Okay. So let's look at set presentation. Okay. So when we look at set presentation, We are going to talk about how sets are actually represented in mathematics, the common way in which sets are represented, and we are not going to go into details. So, the first common way in which sets are represented is actually description. Okay, so the first one is description. So, the first one is description. Now, how do we define sets? How do we represent sets in form of a description? We can say this, e.g., we can say maybe we have set A, then when we say set A, which we can write like this, sorry, we put it this way. These are curved brackets, so I can say set of um, even numbers between 10 and 20. So I've made a set. This is a set already. So like I'm saying, set A is a set of even numbers between 10 and 20. So the objects here are what? The objects here should qualify. The objects here are numbers. Now, what numbers are we talking about? Even numbers. Even numbers. Now, how have we defined them? Those between 10 and 20. So that's how we define. Now, we are using weights here to explain a set. So such kind of using weights to explain a set is what we call description. So we have described a set that contains even numbers between 10 and 20. Okay? Okay. So the other way of representing sets, number two, is what we call listing. Listing. Okay. Now under listing, we are saying each we can have the same set A. Now here we can even list the even numbers that are between 10 and 20, like 12, 14, 16, 18. So we give them out like that. Such kind of representation is what we call listing. So this is a way, another way in which we can uh, present sets or represent sets by listing. So of course, even numbers are numbers that are divisible by themselves and also by 2. So like 12, you can go in it, 14, 16, and 18. So these are in between 10 and 20. Okay? So another one which we have is set builder notation. Okay? Let me just run this part here. So the third way of set uh, representation is what we call set builder notation. So under set builder notation, we can have set A represented like this, where we have maybe x, then we say 10 is less than x, and then x is less than 20. Then we say that mm, x um, is an even number. Oh, sorry, even number, where we say between. Okay, just even number, nothing like saying between, just like that. Okay. So this is another way. Now, this we can read as such. We can say set A is a set of uh, elements such that x is greater than 10 and x is less than 20. So set A is a set of x such that x is less than, or we can say 10 is less than x, and then x is less than 20, where x is a member of even numbers. So it means that I've just stated like this. When I do like this, I've just also stated even numbers between 10 and 20, which are the same: 12, 14, 16, and 18. Now, this kind of representing a set in this way is what we call set builder notation. All right? Then another way of representing set is what we call Venn diagram. So we have also what we call Venn diagram, which is the most common way in which sets are represented at this level, either GCE or grade 12 mathematics. We normally work in Venn diagram. So under a Venn diagram, this is what we can do to represent set A. We can have a triangle like that. Then this one represents universal set. And then we can draw a set there, which is set A. Then we can write now 12. Maybe we write 14. Then we write 16. Then we write 18. So we have represented that information in terms of set builder, in terms of Venn diagram. It means set M is a set of which elements? Is a set of element 12, 14, 16, and 18. The same way as that one, the same way as this one, the same way where we described as set A, a set of even numbers between 10 and 20. So these are just ways you can familiarize yourself, ways in which sets can represented. Now, let's look at symbols used in sets. Very, very important. Symbols used in sets. Okay, now we're looking at symbols used in sets. So I'll run you quickly through symbols that are used in sets so that when you encounter them, you understand their meaning because these symbols have got the meaning, so you need to understand them. So the first one that we are going to look at is actually this one here. So this one stands for member of, member of like that. This symbol in sets, we use it to show that something is a member of another thing. Okay, so e.g., if we have e.g., let me put it this way, e.g., for example, we have set A, the way it was, set A has elements which are 12. I'm going to work with this same one, 14, then 16, then 18, like that. Then we can say that 12, for example, is a member of set A. So this can be read as 12 is a member of set A. So writing this, when you find this written like that in mathematics, it's just simply 12 is a member of set A. That's what this symbol represents, member of. Okay, so I can also put it in this way. Okay, it's okay, like that. Then another symbol that we use in mathematics is this one, which is this, or this like this. So this symbol represents empty set, empty set. That's what this symbol represents. So if I have set A, e.g., if I have set P, for example, e.g., I have set P which is empty, where it says set P is empty. I can write it like this. P is equal to, I write the curly bracket, another one, like that. I put nothing inside there. It means set P is empty. Or I can also do it like this. P is equal to, then I write this. So either this symbol or this way, that means the same. It reads set P is empty. That's what it is. Okay? Or set P is an empty set. So another symbol that we need to look at is N. N like this. Small letter N like this. So N, small letter N, just represents the number of elements. So N represents the number of elements. So N represents number of elements. For example, if we pick the same set AI, so we say e.g., we have the same set A, which has these elements 12, then 14, then 16, then 18, then we may close like that. Okay. Then we are saying that if we were to write like this, N now, then we write like open brackets, we write A, then we write like this 4. This means that This means that set A has four elements. This reads set A has, or it can read that, it can read as the number of set A, the number of element in set A is 4. Yeah. So let me put it in this way. It can read, this can read as this. It means the number of four elements in set A is 4. Yeah, it means uh, the number of elements in set A is 4. So this is the short way of writing this statement. I've written the number of elements in set A is 4. Instead of, because there are how many elements here? 1, 2, 3, 4. Now, instead of me, if I'm asked to say how many elements are in set A, instead of me saying the number of elements in set A is 4, I can write it like this in mathematics. And I've done that. I'll just say n open brackets A equals 4. It means number of elements in set A is 4. So that is very beautiful, right? So that's the beauty about mathematics. Then another symbol that we need to look at is in this one here. Let me just wrap this part again. So we are on 4. So the other one is this one here. This one represents universal state. So now, what is a universal set? It is a set of all elements under consideration. So like a universal set, simply, let me just do like this. A set of all elements, a set of all elements under consideration, under consideration. That's what a universal set is. So it is represented by that. Okay. So for instance, we can have how can we look at a universal set? Let me break it simply in this way. Let's say I have M, which I'm going to say a set or girls in class, like all girls in class. Then I have another B where I say all boys in class. Now, if we were to write a universal set for these two here, it can be like this. Universal set, which is in, it will be now all pupils, okay, in class. That's what it would mean, because the pupils under consideration are girls in class or boys in class. Now, if we combine this and this, it becomes all pupils in class, and that now becomes the universal set. Okay? So another symbol under consideration is C. It looks like C, but it's not C. This symbol like this. This is 5 like this. So this symbol stands for subset. Subset. Okay. So subset is represented by this, and um, a subset is a set of elements belonging to a larger set, a set whose elements belong to another larger set. Yeah. So a subset, by definition, is a set of elements which belong to a larger set. So a subset is a set of elements which belong to a larger set, or a set. A subset is a set whose elements belong to a large set. Okay, that's how a subset can be, a set whose elements belong. Let me just correct it the way I wrote it here. Okay, so I said a set whose elements belong to a larger set, a larger set. So each let's do like this. Each we have set M whose elements are this keyword bracket is giving me here a little bit here. Yes. If I stand here, I may be able to do it. So I have M, B, C, D, then E. Then I have another set which is B, okay, whose elements are M. Then I have B and C like that. Okay, now when you look at set A, it has this element A, B, C, D, E. Set B has these elements A, B, and C. Now, the elements which are in set B, A, B, C are also in set A, which is A, B, C. Okay, so in such a case, we can say set B is a subset of set A. Okay, in other words, set B is a part of set A. Yeah, so that's what a subset can mean, because set B can be created also out of members which are in set A. So what did I say? We are saying all elements in set B are in set A. Hence, set B is a subset of A. So I said that all elements, all elements in set B are in set A. Hence, set B is a subset of set A, which can be written like this. B is a subset of set A in short. So all these set statement which I've said here that set B is a subset of set A can be written in short in mathematics like this. Set B is a subset of set A, meaning set B is a part of set A, like that. Okay, so very important that you understand this. In terms of Venn diagram, we can represent this information as follows. For example, we can have in terms of Venn diagram, a Venn diagram like this. So we can have universal set, and then maybe we can have also set P here. So this one we can say this box here, this box or square represents a universal set. So is a universal set. Then the circle is a subset of E. You can say the circle which is this one is a subset of E, which is the universal set. Why? Because it is inside this. So this is inside the box, and therefore it is a subset. If I were to write another set here, maybe I write it here, I can say that so this one can be written like this. We can write this. Oh, this is okay. So I can also write like E, like, oh, sorry, not like this. Let me put this one as Q, for instance. I can say Q is a subset of E. Oh, not E, but P. Why? Because it is inside the P there of P. So that is how we can see or we can represent that. Okay. So another way, maybe we can have E like the way E is here. Then here we do like this. If I have P, for instance, then I have elements like D, then I have A, then I have B, then I have C like that. Okay. So again, P is still a subset of E. You can still write like P is a subset of E. Okay. Yeah. Now, let's look at set operations. This is more like a full lesson on sets, not going very much in many examples, but giving you the hints or ideas on sets. So it's a very good lesson here because it is giving you almost all the ideas on sets so quick. So we are going to look at set operations. Set operations. So when we talk of set operation, we are talking of these. Okay? We are actually talking of what we call intersection set represented by a big symbol like this. Then we are talking about also union, which is also represented by a symbol like this, like U. Then we have also another one, which is the complement. Complement. Complement set, which is represented by that thing there. Okay. So these are the things we are going to consider here. Okay. So let's start with the intersection set. Okay. Let's start with the intersection set. We need to understand the intersection set. So every time I like explaining these things. So an intersection set is a set of elements which appear in both sets, or it is a set of elements common to in two or more sets. So, so an intersection set would just say um, it is a set of elements common to two or more sets. Yeah. So when we are talking of intersection set, it is a set that we create from common elements, okay, or from elements that are common to two or more sets. That's what we mean. E.g., let me give an example here. E.g., let's say we have set M. It has, okay, when I stand like this, I'm failing to write unless I come like this. So it has elements like 1, 2, and 3. Then we have also set B, which has elements like 2, then 3, and 4. Then um, the intersection set of A and B can exist in such a case, which can be like this. The intersection set of set A and B can be written like this, where they can say list, okay, intersection set of set A and set B. So in that case, it will be a set of elements which are common in set A and set B. So what is common in set A and set B? 2 is around and 2 is around, so we can put it in this set, new set. Then 3 is around here and also around here, so we can put it also here. So this set we have created now, it is an intersection set which comprises elements that are common to set A and also to set B, like that. Okay, so this is how we do intersection set. So sets may not have common elements. So sets that do not have common elements are referred to as disjoint sets. I can just give you that as a bonus point. So we are going to say sets with no common elements are called disjoint sets. Very important. Okay. So what do we mean? Mm, I did explain this one in this way. I just used a Venn diagram. So using a Venn diagram like this, I have here I have universal set, then I have set M, set B, set A, set B. Then I have this one has one as an element, then 7 and 4. Then this one has 2 and then 3 as an element. Then we have other elements here like 9 and then we have 10 here. Now, when we look at listing, this is a Venn diagram. If we are to list it, we can notice that set M has what elements? Set A has elements 1, 4, and 7. Okay. Then set B has elements which are 2 and 3. Then the universal set E, it has everything. It has, I can start from the smallest, all these elements which are here, because A and B are inside this universal set. So they are subset, meaning these elements which are in A and B, they're also in the universal set. So it has 1, 2, 3, 4. I'll start with the smallest 1, then 2, then 3, then 4. We don't have 5. We have only 7, then 9 and 10. So these are the sets. So when we look at, for example, these small sets, not the universal, these subsets, set A and set B, there is nothing common. So such sets can be referred to as the disjointed sets, guys. Okay? I hope this is making sense. Okay? So let's do more examples here. So, we have this information here. We have this example here. Example. This example says if we have a universal set which has 1 up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 as elements. Then we have also set M, which has 1, 3, then 5, 7, 9. Then you have another one which is B, which has elements, which is 2, 3, then 4, 5, then 6, then 8. Then we have lastly C, which has 1, 3, then 6, then 10, like that. Then the question now says illustrate this information on the Venn diagram. It is saying illustrate or show or represent this information on a Venn diagram. Given this information, put it on a Venn diagram. So to put it on a Venn diagram, we'll just write a square to represent a box to represent a universal set. So we'll write it like this. Hope this one is visible. Yeah, it is visible. So I'll write E here. Then I'll write set N. Okay, let me just enlarge it. It looks small. Set N, set B, then set C. So this is set N, set B, set C. So how do we represent this information here? This is the way you can do it. You can do like this. First of all, find intersection set between A and B, then also between A and C, and then between B and what? Oh, sorry, intersection set between B and C. Okay? Then we need to find now the intersection set between A, B, and C. So first of all, let's find intersection set between A and B. The members that are common in B and A and B. A and B. So we see what is common? 3. What else? 5. I think I can see 3 and 5. So here we'll say 3 and 5. What is common in A and C? So this is C. A, we have 1, 1, 3, 3. What else? 1 and 3. Yeah. 1 and 3. I can see 1 and 3. Then in B and C, we come to B, C. What is common? 3, 3. What else? 6, 6. So it is 3 and 6. So I've seen here, we have 3 and 6. Now, for us to find intersection A, B, C, we just look at these 3. What is common? 3. So the intersection is 3. Once we create this, we use it to put here. So this part here, which is also found in B, this part is also found in C, it is also found in A. It is the intersection of A, B, C. So it is 3. We get this 3, we locate it there. Put even a dot there. Then the next thing that we are going to do is to ensure that we allocate um, 3 and 5 between A intersection B. So A is passing like this, okay? Then B is passing like this, okay? So since C3 is already set there, 3 has settled there, so 3 will cancel it. So because even here, we'll cancel it even here because it has already sat in here. So what we are remaining with between A intersection B, in A intersection B, this part here, it is just 5. Then between A intersection C, A intersection C, this part here, which is A and C, 3 is already cutted, so I put a dot here. We are remaining with 1, so put a 1 here and a dot here. Then between B and C, 6, between B and C, 6, so write a 6 there. Then after you do that, you need to come to these which are remaining. Now remember, these which are remaining here. So in this M, which is this part here, you have hammered 5, you cancel it, 3, you cancel it, 1, you cancel it. You are remaining with 7, 9, so you put 7 and 9. Then you come to B. B, it is this part here. You have hammered 5, you have hammered 3, you have hammered 6. You remain with 2, so you write 2, then 4, then 8, like that. Then you come to 6. This, I mean C. This is C. We have hammered 1, we have hammered 3, we have hammered 6. We have remained with 10 only. We'll put here. Now, we'll come to universal indicator. I mean universal indicators, so it is chemistry. So universal set. So we have hammered all these. If you check, these have been hammered there here. We are only remaining with 11, which we can put anywhere. We do like this. So this is how we can present this information into a Venn diagram. Having this skill is very, very important, and this is the simplest way of getting this information. You put it in that way, then you get it into the state like that, then you are home and dry. Okay, so let's see union set. So we did intersection set, and then we can now look at the union set. Okay, as one of the set operations. Okay, so we are looking at union set. So by definition, I said a union set is a combination of elements found in sets. Okay, or elements found in both sets are written once. Okay, yeah. So we are saying it is a combination of sets. It is a combination, or it is a set of. It is a set. It is a combination of sets. Okay, it is a set of. Okay, it is a combination of elements found in sets under consideration. Yeah, that's what I can say. Union set to be. It is. it is it is a combination of elements found in sets under consideration. Yeah. So those sets that are found that are under consideration, if you combine the elements which are there, then you come up with a union set. So elements found in both sets are written once. That is a point to remember. So we are saying elements common, okay, common to sets under consideration are written once. So elements common in sets under consideration are written once. Are written once. Now, agent P, let me let me give an example. Let me put it this way. Example. We have set P, which is set P, which is A, B, C. Then set Q, which is A, O. Then we have P, then Q, like that. Then the union set of, if there is a list, the union set like P union Q, it is going to be a combination of elements in set A and B. But remembering that elements common in sets under consideration are written once. Like if A is found and here we write it once, like this, then we combine B, C, then we combine O, then P, then Q. Then this one becomes a universal set because we have combined sets, elements in set P and then elements in set Q, and that becomes the the union set, mean you get elements in set Q and elements in set P, you combine them, but any element which is common in two sets, you write it once like A. You don't have to say A is there, you write it again, and here, no, you don't do that. Okay. So that is it, the concept there. So in a Venn diagram, we represent it like this. In Venn diagram, it will be like this. We'll have intersection. I'll do intersection here first. So we can have E here, then I can have A or this set. So this is P, this is Q. Then we can have the common one is A, it can sit here. But here we can have B, then and D, C there. Then here we can have O, P, then Q like that. But in terms of union, I can draw the same one. Then I can say E, then this is P, this is Q. Now, in terms of union, now, I'll say here M, then B, then C, then O, in terms of union, we can end up shading this. Let me look for my red marker. I think we can end up shading this. That will represent the universal, I mean the union set, meaning we have combined set P and set Q like that. So another set operation that we need to look at is complement set. Very, very important, these concepts here, guys. Okay, so if you are watching on my channel, which is the DMS Online School, remember to give this video a like. If you have already downloaded it, go and like on the channel, and also let me know in the comment section. Why is liking very important? Because it helps this video to be shown to other people by YouTube, or it also informs YouTube that this video is a very important video. Okay, so that is the main importance of liking. Maybe some of you have discovered it because someone had to like it, so YouTube had to show it also to you. Yeah, so let's look at complement set. Complement set. So a complement set is a set of elements. It's a set of elements, not members of a set under consideration. So I'm going to say it is a set of elements which are not members of a set under consideration. Okay, so that's what a complement set can be. It's a set of elements which are not members of a set under consideration. Okay, so again, I did it like this. Again, if in X is a set, comma, and I said then its complement is written as this. Okay, then X complement, then its complement is, let me just say is like that. Okay, now what does that mean? It means this engine, okay, if in member of set, okay, let me just not use this one, let me use this one as an example. There I'll confuse it. So let's put this example here where we have seen if the universal set has got these elements such as 3, 6, and 7, 9, or 8, then 9. Oh, there's actually no 8. There's actually 9. Wow, then 2, then 0. Oh, what I said. Then A, we are told also we have A, which is a set of 1, 4, then 8. Okay. Then If the question says list a complement, it means you need those which are not in A. So we know that A, it is these are the elements. So A complement, it means it is they want elements which are not member of a set under consideration. So the set under consideration is A. When we say A complement, members that are not under this set. So we can pick them from the universal set, like 3, or we can start from 0, it's not a member there. 2, it's not a member there. 3, it's not a member there, right? Yeah, almost everything here, I think. 6, it's not a member. 7, it's not a member there. And 9, it's not a member. So this becomes the complement of set A, meaning elements that are not member of set A. Okay. Now, in terms of a Venn diagram, how can we show this information? In a Venn diagram, let's say we have a Venn diagram like this. Then you have universal set. Then you have also set A here. Inside set A, we have only 1, then 4, and 8. Then outside, we have 0, then we have 2, 3, then we have 9, then 7, then maybe 6 there. How can we show the complement of set A? Simply, we can just shade these elements outside A, like this. By so doing, we would have found uh, elements. So these are elements which are not part of set A. So this presentation and this is listing, this is using Venn diagram. Okay. So let's look at the combined operation. Combined operations. Combined operations. So when we talk of combined operation, we are talking about using intersection set, union set, and the complement together. So it means using intersection set, union set, and the complement set together, or in one. We use these in one, then we come with the set operations. So let's first go through this example. This example says that if universal set is equal to 2, 4, then 6, 8, then 10, then 12, So this is a universal set, and then we are given F. We have 2, 4, and then we have C. We have 8 and 2. Then the questions comes and say list, and let's say 1. We are told to list, or we already have one thing here which we are told to list. List open brackets F intersection C, then complement. So out of this information, they are saying give us list F intersection C complement. So for you to be able to answer this question, this is what you do. First find this F intersection C. So you come to F intersection, those which are common in F and C. So when you come in F, you find the 2, here 2. Okay, it's just 2 which is common. So you say, okay, 2 is the one which is common. Now, when they send F intersection C common, I mean F intersection C, then complement, then meaning now you list those, you exclude this, you exclude, it means exclude F intersection C. This means exclude F intersection C. So we have found F intersection C, which is this. Now, with this, it means we make a set that should exclude this. So therefore, it will be now like this. Open brackets F intersection C complement. We should just come up with a set where 2 will not be there. So we can start with 4, then 6, then 8, then 10, then 12. That is all. That is it all. So these are not part of this. So that's how we can answer such. And another one, if it were to be represented in terms of a Venn diagram, it would be like this. In a Venn diagram format, let me see this marker. Okay, so let's see. So it will be this one is E. Then we can have okay, we can have F, then C. The intersection between these two guys, which is this one we found 2. Then the rest here we have 4 here. Then here we have 8. Then the rest are these 6, 6, 10, 12. So 6, 10, 12, I think. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. So if we were now to show where they say we show this, so we know the intersection is this part. Now, this information can also be shown by just shading this like this. We just shade this part like that. Okay. Oh, sorry, including this part here. We only leave this part in and shade it. Okay. So that's how we can do it. So Let's have another question. We are almost there. We are almost there. This is a very good lesson on sets. So let's do it again this way. So let's have another example. We have this example, which is example one, where we have a universal set here. Then we have three sets: one, two, three. This pen, this marker is done. So we have A, B, C. Here we have A, E. Here we have I, then C, H. Here we have L, then here we have J, then K. Here we have G, then B, then F, and they are nothing. Then we have questions which said list A, we list A intersection B, then B, we list C complement. Yeah, they're just two. So in answering this, it will be simple. A intersection B, A intersection B, those elements which are only intersecting B and A. So which one are those? This is found in A and B. Also, this one is in A and B as well. And also this one is found in A and B. So we can say A intersection B, we do like this. Then we'll put B, F, then G. That is all. Then we come to B, C complement. So C complement, for us to know C complement, first let us list C. C, it is this. So C, we have G, then we have J, then we have K. Now, complement, it means we don't want those that are in C, those that are not in C. So therefore, say complement are those that are not these. We'll pick these now. Again, L, E, then we come to maybe B, or that doesn't matter, F, then I, then C, then H, then this L also here can get included. So that's how we can tackle that question as that. So we are done with that. Let's go to question example number 2, which happens to be the last one and very, very helpful. So pay attention, guys, pay attention. Mathematics is an interesting subject. So, question 2 says of 150 students, we are told, let me put it in this way: 8 take history, take history as a subject, then 50 take maths as a subject, then 70 take biology as a subject, then 30 take both history and maths, both history and maths, then 40 take both history and biology, then 20 take biology and maths, so take both biology and maths, then 10 take all the subjects. Then question A says illustrate this information on a Venn diagram. This information on a Venn diagram. Then B, find the number of pupils who take it. Find the number of, actually we are dealing with students who take it. 1, maths only, then 2, biology only, then 3, history only. Okay, so let's go for solutions. I'll put the solutions here. So, A, they want us to illustrate this information on the Venn diagram. So, we have how many subjects? History, maths, biology. So, you write a Venn diagram with a universal set like this. Then this is E universal. Then you write here set A, set B, set C. So this one becomes history. Just put H. This one put mathematics. And this one biology. So how now do we put this information into a Venn diagram? When you are putting this information into the Venn diagram like this, always start with this part which says take all the subjects. You start with that. So you come with the one which takes all the subject, which means it is an intersection. So take all the subjects means in intersection, which is this part. So you put it 10 there. Once you are done with that, then you can start answering the rest. So you can come to those that take both now, like here. Those with history and maths. History and maths. So you are told how many take history and maths. There were 30 students. So you are supposed to put 30 here for history and maths. Now you remember this 10 also is already for maths and history. So in that 30 meaning, remove the 10, you remain with it, the 20 you put here. So that when you say 20 plus 10, you get 30, which is also in maths, which is also in history. Okay? Then once we do that, you can also come for the next history and the biology. So history and the biology. How many? There are 40. So you need to put in history and biology 40 here. But again, out of that 40, 10 are already here with the biology and history. So you say 40 minus 10, you remain with the 30. Then you come to this again for history, biology, and maths. Biology and maths, how many? 20. Now 10 are already here. So 20 minus 10, you remain with the 10 like that. Then after you do this, you are done. 1, 2, 3, 4. You are done. 1, 2, 3, 4. You come to these which are remaining. So you come to history. They were supposed to be 50. I mean 80 in this history. Only going around here, you're supposed to have 80. So, but out of 80, we have already these that are seated here. So 20 plus 10, which is 30, plus 30, 60. So we have 60 seated here. So if you say 80 minus 60, those that will remain should just be taking history here. So which will be 20, of course. Okay. Then you come to maths. Maths you feel here. Maths you have 50. But here, from here you need to have 50. So you have 20 plus 10 plus 10, which is 40. So like 50 minus 40, you remain with the 10, write it there. Then you come to biology, 70. But here you have 30 plus 10 plus 10, which is 40. So 70 minus 40, you remain with the 30 here. Okay? If not mistaken. Mhm. Oh, this is 20, sorry. So this is 30, 40, 50. So here you remain with the 20. Now, the remaining part is these guys, when you total them, you get this plus this plus this plus that plus that plus that plus that. You should at least get 150. Okay? But if it doesn't give you 150, then you subtract 150 minus what you get there. So in this case, what we are going to get is the 30 will remain with the 30 here. That's what I found. You can go through. After I total this, then I say 150 minus that total, I will remain with the 30, which I'll put in the universe. Meaning these, they never took any of these subjects. So A has been answered. Now we go to B. B, they are saying find the number of students who take mathematics only. So those who take mathematics are these that are not found in B or in biology or maths, history these. So for maths, one is saying 10 take maths only. Then two, those who take biology only, they are here 20. These which are here. So say 20 take biology only. Then three history. History, they are here 20 again. Say 20 take history only. Okay, so this is it, guys. So this is how you answer these questions in mathematics on set. I think I've touched most important things on it. Sets, maybe if we will do another lesson on sets, then it will be about an exam question. So guys, this is about maths, and this is where I come to end on this lesson on maths. I hope you have enjoyed it. If you have, please consider giving this video a like and let me know in the comment section, and also consider liking and subscribing to the channel so that when I post another video, YouTube will be able to notify you. Thank you for watching for now. Bye and see you in the next lesson. Peace.